Now we're going to calculate the latitude of the vertex as our first step towards actually identifying the location of the vertex. I did decide to leave L2 here. I'm just going to keep it crossed out so you know it's no longer important. And I also figured that even though we're just going to be punching the course angle into the calculator and we're just leaving it as a rote number, it still is good form to leave the notation on either side so that we remember, yes, it is north 60.72 degrees east. And if we were going somewhere else, it might be north 60.72 degrees west. So I'm just going to keep that to the side so you remember that that's how you should properly write it. But we're keeping it as just T for the most part anyway. Now, for the latitude of the vertex, we're only using L1 and CA. So you can think of our starting location, and we know we're starting here and we're pointing this way off that angle. So if your starting location was this far from the equator and you were pointing in this direction, what would the latitude of your vertex be if that was a point along a great circle? And that's what it's going to give us. It's going to give us this line here, not how far away we are from it, just what the latitude will be as this slowly tapers off, finally comes to its northernmost point, and then slopes back down to the south. So it's the cosine of the latitude of the vertex is equal to cosine of L1 times sine of the course angle. So we're going to write cosine LV is equal to cosine of 19.3 times the sine of 60.72. Now we're going to come here. I just want to test that T can be recalled. Okay. So cosine of X, because that's L1, times the sine of T, because that's CA, gives us that. We then do cosine inverse of the answer. We get 34.6. So we can write down LV is equal to 34.6. Now this is in degrees. It's really important to note here, we now need this value both in degrees and in degrees and minutes. Because for the math, this will be incredibly important for calculating the next variables using the next formulas, which for that, we will need to keep it in whole degrees, just like we've been keeping everything else. But this is also the latitude of your vertex, and your vertex is gonna be one of your waypoints. So you're gonna need to convert it to degrees and minutes so you can actually have that point along the track line for you to be able to aim towards. So we're gonna write off to the side here, LV is 34.6 degrees, and just like everything else, we're going to store it, X, Y, Z, T. Next one is A for whatever reason. So now A is 34.6. So we're going to say that this is equal to A. And remember, 34.6 is this distance here. It's the latitude of this line, which intersects the vertex. We don't know where the vertex is. We just know that this is the vertex's latitude. Separately, we're now going to calculate its latitude in degrees and minutes, just so we can have that for later on. You'll see why. So we subtract 34, get just its just the decimals of a degree, multiply that by 60 to convert it to minutes, 36.4. So I'm going to write off to the side, vertex is 34 degrees, 36.4 minutes north. 403, but that doesn't matter. And then when we finally find its longitude, we will add that to the vertex. But right now, we just have its latitude. So going through this equation, using these principles, we found LV is 34.6, which we're going to treat as A for our next set of calculations. And our vertex here has the latitude of 34 degrees, 36.4 minutes north. That's the most north we should ever be following along this track line.